This is another group teaching problem that we went over in class when we circulated among groups. It's also on the practice sheet. It's also on tomorrow's quiz. Number 7 is about a classic physics problem. It's the speed of a satellite. It seems like you're not given enough information here, but you'll see that if you follow the usual steps, you will have enough information. The key is write down the equation before you worry about the numbers. Write down the equation before you worry about the numbers. And the main equation of interest here is the centripetal force equation. The centripetal force equation is F sub c is equal to mv squared over r. And the real focus here is this centripetal force, because the question is, what forces make up the centripetal force? This is the key question here. What forces combine to make this object move in a circle? Those forces vary from problem to problem. The theme that you saw when you went from board to board to board was really all tied by the same question. It was, what are the forces in this particular situation that make the object move in a circle? And what we discovered is that changed. It could have been tension, it could have been weight, it could have been normal force. In this case, it's the gravitational force. If you look at this satellite and you think about the forces that are on it, there's a gravitational force, F sub g, I'll call it, pulling the satellite in toward the center of the Earth. There's no strings on it, there's no friction on it, it's in space. The only thing that could possibly be affecting it would be the gravitational force. So I'm going to write down gravitational force. So gravitational force is mv squared over r. And notice, I'm not worried about numbers yet. I haven't worried about numbers. I'm just trying to get a relationship here. So now I'm going to put in the expression, and this is what I think is the most important step in this whole process. And you're going to see me put very little emphasis on numbers here and a lot of emphasis on the equations. Now that should look familiar. This equation that I just drew should look familiar. I just wrote this. But you're used to seeing it as g m1 m2 over r squared, but then the m1s and m2s get confusing. So I like to write it in terms of the big M being the mass of the planet, the big M being the mass of the planet, the little m being the mass of the satellite. So now what you can see is that I wasn't given them, now we are going to kind of start thinking about numbers a little bit. I wasn't given the mass of the satellite, but that's okay, I don't need it. It cancels out, which has an interesting implication. It actually means that no matter what the mass of the satellite is, for a particular space in orbit, you need to give it a certain velocity. Okay? So now I can simply plug in numbers, and I'm not going to focus on the number plugins. I'm just going to say known, that's the mass of the planet. This is unknown, it's what we're trying to find. We know R, we know R. But let me explain a little bit how we get R. We are looking at numbers now. We don't know R right away, but if we do a little bit of work, you'll see that it's that distance, which I'll call D, plus this distance to the center of the Earth, which I'll call the radius of the Earth, or R. So you have to add up those two distances. And those are in kilometers, and this is where the numbers get a little bit ugly. But what I'm going to do is write down, the R is equal to the 6,400 kilometers, which I'll write down in meters, plus the 5,000 kilometers above the surface of the Earth, which I'm writing down in meters. It's about 6 million plus about 5 million, so it's about 11,400,000 meters. You plug those numbers in. You solve for V. You get 5,915 meters per second. I'm leaving the algebra to you. And I'll pause for questions from the... There were 2 points of clarification that were just asked by an anonymous student. I'll call him Henry. Just, this will be on YouTube. I don't want to use real names. But he asked regarding this equation, could you cancel out the r squared and cancel out this r? The answer is yes, you can. And he said, does that mean you end up with v squared is equal to gm over r? And yes, that is true. You do end up with that. That confuses some people, the r squared and the r, and I just don't want to get into it. It's a little more obvious that these masses cancel, so that is necessary and a little more obvious. And the other question he said was, so you're just leaving the math to us? And I'm saying, yes, I'm just kind of leaving the math to you.